Okay, here we go. 5/10/2019, my birthday. Yay, me. There you go. So, let's go through this. It's actually pretty simple to create. So, let's go ahead and also add in pi force. And when I made my chart, I went every 4. And the reason I went every 4, you'll see in a bit, because there are really 5 spots in my unit circle I like. 5 spots are going to be really 0, 90, 180, 270, and back to 0. Okay, those are the important spots. In between, we'll hit the 45s. Okay, in between, we'll hit 125, we'll hit that 225, we'll hit that 315. Okay, so this is going to, in a sense, be rolled. It's going to make a curve. It really will. Okay, so right off the bat, look at the y values. At 0 radians, what's the height or the corresponding y value? 0. You guys agree? Here's my 0 radians, and my y value is 0. See I'm doing it? 0 radians, because my x-axis is my degrees, or my radians, and my y value is 0. So I got to point at 0, 0. Okay. At pi force, here's my pi force. My y value is square root of 2 over 2, which is about 0.7. Okay, it's about approximately 0.7. So at pi force, we're going to go to about 0.7. So we'll estimate 0.7, maybe about there. Okay. If you get confused, will you stop me? Because I think this is easy, but that's me talking, and I'm the guy who's been doing this for 35 years, right? So at pi halves, right? What's the corresponding y value? 1, right? See how this is working? So you get a value of 1. Okay. At 3 pi force, right? 3 pi force, what's the corresponding y value? Did you guys see it?
It's a negative square.
The x is, but the y is.
Oh.
Plus, think about this. The y value is the height anyway, right? Does that make sense? The y is the height. So it's square root of 2 over 2, which is approximately 0.7. Square root of 2 over 2 is approximately 0.707, blah, blah, blah. How do I know these things? Because I'm crazy, insane, been doing this forever, right? So, at pi, what's the height? What's the y value? 0. We agree at pi, the height is 0, or the y value is 0, okay. So then if I go to 5 pi force, right? If I go to 5 pi force, what's the corresponding y value? Negative, right? Yes, negative square root of 2 over 2, which is negative 0.7. Good job, Daisy. Good job, Saul. So approximately right there. At 3 pi halves, what's my corresponding y value?
1.
Negative 1, right? Negative 1 is right here. 3 pi halves, it's right there at negative 1, right? So negative 1. And then at 7 pi force, okay, 7 pi force, it's going to be at a negative square root of 2 over 2, which is negative 0.7. And okay, I'm all the way back to 2 pi, and the y value is 0, right? Okay. This is one sine curve, so let's just draw that in. And it's supposed to be curvy. Okay, this is one sine curve. Okay.
Sine curve or sine wave?
Sine wave. It will be a sine wave. So when we apply this to science, we call it a sine wave. Okay. Yeah, Daisy?
It looks like an exponential equation.
It kind of does, except for this is going to continue to go. So it's what we call a periodic function. So it's a periodic function. Let's write that down. Periodic function. Periodic function because it keeps going. Same pattern over and over again. That's what periodic means. A periodic function means this pattern's going to keep going and keep going and keep going. And obviously, waves, think about the ocean wave, right? They just keep going and going. Yeah, Gavin?
Okay, so
Go ahead.
Stand
Yeah,
up.
you're catching up, so ask any question you want.
so here's this 7 pi over 4.
Yeah. Here it is. Here's my y value.
No, I feel stupid now.
No, it's okay. You missed 2 days, so I don't mind you asking any question you want, okay?
Wait, so you start right here, right?
I started there. Yep.
And then the first point up here.
See how it's going up? It's going up. It's going up. Your hand's going up too, isn't it? So your hand's going all the way up to 90.
Okay.
And what's the height at 90?
1.
You're good. And then you start going down. See how the curve starts going down, the height starts going down until you get to pi. Good. And then it's going to start hitting the negatives, right? See how it hits the negatives? And then all the way 3 pi halves, it's at its lowest spot, isn't it? Right? What's the lowest spot? Is it -1, right?
Oh, because it's
And then it goes back up.
circle.
It's pretty cool, right? Now, if it's a periodic function, this curve has a period of 2 pi. The period is the width before it repeats. Does that make sense? The period is the width before it repeats again. So how long is it? They'll talk about the length of a wave in science. And the wavelength, I know you've heard these terms before, the wavelength is 2 pi. Okay? Right? That's its period. Now, its height is called the amplitude. Okay, so it has an amplitude of 1. Yes, of 1. Right? And if I want to get really big and loud, the amplitude gets bigger. Right? I didn't say that word. All right? Now, cosine looks just like the sine, exactly like the sine, except for where it starts. So now cosine is going to be my x values, right? So if I go to my x values at 0 radians, what's my x value? 1, right? 1. So it starts up here. In science, we don't really ever say a cosine wave. Yeah, we never say in science a cosine wave because most things start at 0. Does that make sense? But we still can have a cosine wave. So then at pi force, what's the corresponding x value at pi force? Right, square root of 2 over 2, we're doing the x values, right? Square root of 2 over 2? Okay, or 0.7. So it'd be about there. Pi halves, what's the corresponding x value? Yes. Thank you so much. So, yeah, what's the corresponding? Yeah, I heard 0. Did you agree with 0? Okay, 0. Pi halves, x value is 0. Okay, and then at 3 pi force, I think it's a -0.7, right? -0.7 because we're x values are back over here at a -0.7, which is down to -0.7. Okay. And then at pi, the corresponding x value is -1, right? You guys see that? And then at 5 pi force, it's at a negative square root of 2 over 2, right? 5 pi force, it's at negative square root of 2, which is about -0.7. Okay, and then 3 pi halves, the x value is 0, right? At 7 pi force, the corresponding value is at square root of 2 over 2, or about 0.7. And then back up to 1 when we get to here. Okay, so then it's the exact same curve, same shape. The difference is where it starts, okay? It starts up at a height of 1 instead of 0. And there it is. Now, most applications in science are going to say it's a sine wave. However, we can call it a cosine wave because it's a math class, right? But you'll always hear things like a sine wave. You'll hear about a wavelength, right? And you'll hear about amplitude, right? And you'll hear about its period. We're going to talk about those too, okay? So, all right, the period of this function is its width. How wide is it from beginning to end? 2 pi, right? 2 pi. What's the amplitude? How high is it? Amplitude is also 1 because it goes to a height of 1 and down to -1. Okay? Pretty simple. Now we're not going to do a lot with this. We will in pre-calculus. We'll do a lot with it. But in Algebra 2, we don't need to do a lot with it. Yeah, Cole?
So can you explain real quick, why does it start at 1?
Great question. Okay? So let's look at this point right here. Okay? We know that cosine is the corresponding x values. Right? What's the x values here at 0?
1.
Right. And that's all I'm doing is graphing angles. I'm graphing angles and their corresponding x values. So as far as a point, you've got a coordinate point. My point is angle x value, angle x value, angle x value. That's what I'm graphing. So my x value is 1 right here, angle X value, okay? That's what I'm graphing. Okay, does that help? Yeah, Caleb?
And then like when you look at waves of like UV radiation or whatever, it keeps going.
Yeah, they keep going.
So what would a mathematic like equation be?
We're going to do those. Not today, but we're going to do those. We're actually going to look at waves Monday. And if I set it up, we'll actually get an oscilloscope in here, and you guys can actually talk into it and see your wave, okay? See your voice. Or you can sing into it or whatever, right? If I get my act together, I'll have it set up, okay? But we're going to look at that. We're going to actually, on Monday, look at the wave and figure out what the equation is, because we can do it. Okay, now, you ready to turn the page? Okay. Now, if we turn the page, we're going to do y equals a 3 sine of 2x, okay? So there's going to be two things. First of all, we're going to take our sine wave, and we're going to do two things to it. One, first thing we do is we're going to change its amplitude, okay? So the amplitude is now equal to 3. So instead of going up to 1, 2, I'm going all the way up to 3, okay? -1, -2, and -3. Okay, so it's going to be much taller. That makes sense, right? Now the 2, you got to listen carefully. The 2 doesn't make it twice as wide. Does not. It makes it half as wide because what we want is 2 curves. We want 2 curves. So to get 2 of these curves, we'd have to make it half as big. So we'd have 1, 2. I'll show it again. To get 2 curves in this space, we'd have to go 1, 2 curves, right? If I need 2 curves between 0 and 2 pi, if I need 2 of these between 0 and 2 pi, I'd have to make each curve go from 0 to pi. Does that make sense? Okay, if I need to get 2 in here, I'd have to make each curve be half as wide. So I can go 1 here and the second one here, okay? Yes.
So you can put it in a fraction, would it then be half as long?
Yes, so the period is going to be your 2 pi divided by your 2, because we need to take our 2 pi, which is our normal period, and divide it into half. So we get 2 of them, right? So our new period in this one is going to be pi. Okay, so when I put down my graph, I'm going to do the same thing. I'm going to go ahead and do I'm going to do the same scale. Okay, so I'm going to go pi halves. I'm going to go pi. I'm going to go 3 pi. Did I do the same scale? Nope, I'm off. My bad. Let's go pi halves here, pi fourths, pi halves. 1, 2, 3, 4 pi. 1, 2, 3, 4. 3 pi halves. 1, 2, 3, 4. 2 pi. Okay? I'll put in my 3 pi fourths. Just a second, real quick, and I will take your question. 5 pi fourths and 7 pi fourths. Okay, go ahead.
Okay, so at the first point on the x-axis.
That's pi fourths.
Pi fourths, okay.
Which really makes that pi eighths, doesn't it? Right?
No.
It really does make that pi eighths, right? Okay. So I'm using graph paper because it's easier to put these on graph paper, right? And I'm putting the important. The important ones are pi fourths, pi halves. These are the important ones. These are the ones that we could put the others in here, but they're in there somewhere, okay? But it's much easier to just go by fourths because it's easier to graph, okay? All right, now, so far so good, right? I want to put my sine curve here. I want to put one side curve here between 0 and pi, right? It's going to have a height of 3, okay? So here's how I do it. Flip the page. Let me show you. There are 5 important points. I'm going to highlight them. The beginning and the end. For the sine curve, the beginning and the end start at 0, right? So the beginning is at 0, the end's at 0. The height's 0, right? In the middle, halfway, is also at 0. Does that see what I'm doing? 1/4 of the way, it's at its highest spot. 3/4 of the way, it's at its lowest spot. Okay, so these 5 points are going to help me graph this. Okay, you guys see the 5 points? Beginning end has a height of 0. The middle for sine has a height of 0, right? The 1/4 of the way, the height is at its highest height, and 3/4 of the way, it's at its lowest height. So if I do that here, okay, I'm going to put my points down. So I'm going to go like this. I want this shape, and I'll just do it on the side. Okay, here's my sine curve, okay? Here's my sine curve. That's a sine. It's So put it on the side. You need that shape here. So, between 0 and pi. So this shape has to go between 0 and pi. This shape is going to go between 0 and pi. So I can put another shape between 2 pi and 2 pi, okay? So it's going to look like this. Boom, 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 way up here, and way down here. Okay? So my graph is going to look like this. Okay, there's one of them. There's one of them. And it has an amplitude of 3. I go up to 3 and down to -3. I have one curve between 0 and pi, so that I can put the second curve in. So I can have two curves. I want this shape. I want this shape right here between pi and 2 pi. Here, here, boom, 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 and boom. There it is. And Caleb's right. It does keep going and keep going and keep going. Okay, I just drew two of them. But technically, it really does keep going and keep going and keep going, right? So, I'll back up. I have an amplitude of 3. Goes up to a height of 3 and down to -3, right? And I have two curves. I got two curves between 0 and 2 pi. Thumbs up, sideways, where you at? Okay, thumbs down. That's it. Well, I'll keep working. Okay, now let's look at the cosine, okay, real quickly. So now, the cosine curve. Cosine curve looks like this. It looks like this, okay? That's what our cosine curve looks like. If I just flip it over, there it is. There's my cosine curve, and it looks like that, okay? All right, so now, let me put in my important angles. I'm going to go pi fourths. I'm going to go pi halves, 3 pi fourths. I'm going to go pi, 5 pi fourths, 3 pi halves, 7 pi fourths, and 2 pi. Okay? Now, if I'm going to go all the way up to 4, I might just change my scales. I might just go by ones. You okay with that? I mean, like 1, 2, 3, 4. Otherwise, I'm going to go off my page. 1, 2, 3, 4. I'm just going to change my scales. Otherwise, I'm going to be way off my page. Okay? But I just changed my scales. I went by ones instead of by 1/2. Okay? Now, I need two of these curves. So, first of all, my amplitude is a height of 4. That's my amplitude. And then I need two curves. So my period is 2 pi divided by 2. Because I'm going to take my 2 pi, my total, I'm going to divide it into two parts, right? So I get two curves, okay? So my new period is pi. Okay, so from here to here, I need this cosine curve, right? From here to here, I need this cosine curve. Okay, so it's going to look like this. Now, the important points on the cosine, everybody watching, are going to be these points. There, 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 and there. Okay, you see the important points? Those are the points I'm going to graph. Okay, so I'm going to start up at 4, and I'm going to end at 4. Okay, see if that makes sense. I'm going to start up at 4 and I'm going to end at 4, okay? Then halfway, or pi halves, I'm going to be down at -4. At that point right there. So that point right there is there. Now, at 1/4 of the way, I'm going to be at 0, or pi fourths. 3/4 of the way, or at 3 pi fourths, I'm going to be at 0, okay? So there's one curve. There's one cosine curve between 0 and pi. Amplitude of 4. Now I need to put the second one in. So same shape, this shape, between pi and 2 pi. So, all right. Here, here, okay? Starts and ends at a height of 4. Halfway through, or 3 pi halves, it's at -4. 1/4 of the way, it's right here, 5 pi fourths and 7 pi fourths. There it is. Isn't that cool? Okay, and of course it keeps going and going and going. And that's all I have. In pre-calc, we will do a lot more with this, but this isn't pre-calc, okay?